Hello everybody. We're going to be graphing linear functions in this video. We're going to be looking at graphing using slope-intercept form, standard form, and also point-slope form. So here's just kind of a step-by-step that you can use, and you can pause this and put in your notes, or you can rewind and come back to it. But once again, we're going to look at slope-intercept form and standard form, and then we'll also look at point slope form. Okay, so with slope intercept form, remember that you're given the slope and the y-intercept pretty explicitly when you're given the equation, and so you can identify those, identify the y-intercept and plot it, and then you can use the rise and the run to find the next point and then connect the dots with a straight edge, aka a ruler. All right. So, and then with standard form, probably the best method is to find the x-intercept and the y-intercept, and then once you plot those 2 points, you can once again connect the dots and draw the line through those 2 points. So basically all you need when you're graphing a linear function is 2 points. Once you get 2 points, then you have essentially the slope, you have the line, so you can just connect those dots and you can extend those all the way through the graph given. All right, so here's the procedure in using the y-intercept and the slope. So write the equation in slope-intercept form, right? So that's the first thing. So if it's not in slope-intercept form and you want to use this method, right? Remember there are other methods. Then first of all, get it in slope-intercept form, and then once again plot the y-intercept. And from the y-intercept, you want to use the rise and the run to locate a second point, right? Remember, we need 2 points to graph a linear function, and then we can just draw a line through the 2 points, right? Like I said, connect the dots, and really more than connect the dots, extend through the dots. Okay. All right, and you'll see all that in this example. So number 52 here. So we have the equation already in slope-intercept form, y equals negative 4x plus 1. Okay, so what I'm going to do is identify the slope, which is negative 4. Okay, and I can even remember that, okay, there's going to be negative 4 over 1, right? Because that's the rise and the run. So the rise is 4 and the run is 1, and it's negative, so it's going down to the right. And then the y-intercept is positive 1, right? So remember that's going to be 0, 1 are the coordinates of that y-intercept. All right, so I'm going to start there. I'm going to put a dot or a point right on the y-axis at 1. Okay, and then I'm going to use the slope, negative 4 over 1, to find the next point. So remember, with negative slope, you can either go down and right, or you can go up and left. All right, so either way works, but we want to use so it kind of sometimes depends on where you have room on your graph, but usually when you're using this method, you can go either way because you're going to start right on the y-axis. So we'll go down and right. So I'm going to count 4 units down, 3, 4, and I'm going to count 1 unit to the right, and that's where I'm going to put my point. Okay, so slope of down 4 over 1. All right, so now I can get a straight edge and connect the dots. All right, it doesn't work as well as I would hope on this touchscreen here, but finally got the line going, and so then just draw arrowheads on either end, symbolizing that it goes forever in both directions. All right, so that's how you graph a linear function. With a lot of curves that come later, like quadratics and cubics and so forth, and rational, and you'll need more than 1 point a lot of time, or more than 2 points, excuse me, a lot of times to graph those lines. So linear functions are nice because you only need 2 points. All right, so here's another. So number 53. So the slope is 3 over 4, positive this time. And the y-intercept is negative 2. So 0, negative 2 would be the coordinates for that, right? So I'm going to plot a point, 0, -2, and then I'm going to use the slope, the rise and the run, to find the next point, right? So a positive slope, I can go up and right, or I can go down and left. So I'm going to go up and right. So I go 1, 2, 3. That's my rise. And then my run is 1, 2, 3, 4. So there's my next point. Then I'm going to use the straight edge to connect those dots or extend through those dots. All right, that time it was better with the straight edge. Okay. All right, and that's it. And one other note, remember, if your equation is not in slope-intercept form and you want to use this method, then just solve for y, right? Isolate the y, get it by itself so you can get it into slope-intercept form, and then you can do this method, right? So this method always works with any linear function as long as you get it to slope-intercept form, okay?